Good evening, everyone. So I'm Jakub, and I'm a iOS software engineer at Job and Talent. And tonight we are going to talk about something every mobile developer knows too well, that exhausting dance between Figma, Jira, Notion, Slack, and your code editor, which is probably Xcode. But more importantly, I'm going to show you how we've eliminated most of that context switching using AI coding tools. And by the end of this talk, you will have a blueprint for building your own AI-powered workflow. Let's start with the painful truth. Look at your typical day as an iOS engineer. You've got your Figma open for designs, Jira for tracking, Notion for documentation, Slack for communication, and somewhere in there you're supposed to actually write code. Each of those tools is great at what it does, but they don't talk to each other. Every time you switch between them, you lose focus and your momentum. Let me make this concrete with a typical scenario. A designer updates screen in Figma, you manually extract the specs, convert measurements to Swift UI code. Meanwhile, your PM wrote the PRD in Notion, you read it, interpret it, create Jira tasks yourself. Then a bug gets reported, and you are hunting through Slack, Notion, and code to piece together what happened. Finally comes code review. You are jumping back to Jira, Figma, checking docs, just to verify if your implementation matches requirement. And each of these steps burn cognitive load and introduces potential for errors. This is a death by 1,000 content switches. And here's our roadmap for tonight. First, we will establish the problem, and I think we just did that. Then I will introduce MCP, which is Model Context Protocol that connect Cloud Code to your tools like Figma and Jira. Next, I will show you our actual setup. 7 specialized subagents that handle everything from code review to PR creation. After that, I will teach you how to build your own subagents. Finally, we will look at what we are experimenting with next at our company. The goal is simple. By the end, you should be able to go back and start building similar workflows by yourself. Before we dive in, let's be clear about what we are optimizing for. We want everyday workflows to be efficient, not revolutionary, just smooth. We want to eliminate repetitive tasks that waste your time. We want to improve how we use Cloud Code, because frankly, without proper integration, it won't solve context switching problem. And critically, we want to keep engineers engaged with interesting problems, no data entry between tools. Here's our typical feature development workflow. It starts with a PRD in Notion, includes designs in Figma and tracking in Jira, and ends with implementation and tests. Nothing unusual here, probably looks like your workflow too, maybe with just a different tools. The question is, how much of this can we automate while maintaining quality? This is where it gets interesting. Instead of manually bridging these tools, we use MCP servers directly connected to Figma, Jira, and Notion. Cloud Code becomes your AI agent that understands your entire workflow. You use natural language like create task from the PRD instead of copy-pasting. And here's the key insight. MCPs bring the tools to you, but subagents handle the complex multi-step workflows. Think of MCP servers as the hands and subagents as the brain that controls it. And I like to call the Cloud Code my command center. One interface for everything, no more juggling windows. You give natural language commands instead of clicking through UIs. And MCPs make all these tools accessible from Cloud. Subagents handle the multi-step processes. And critically, context preservation. Your entire workflow history lives in one place. Let me show you what it looks like in practice, starting with MCPs. And MCP stands for Modex Control Protocol. Cloud Code communicate with MCP servers using it. And let's start with the most visual one, Figma. Figma MCP gives Cloud direct access to your design files. No more screenshots, no more manually measuring spacings and all other details. And there are 4 core functions for mobile development that I found useful. Get design context extracts complete design specifications. Get variable defs pulls design tokens, color, spacing, typography. Get metadata, discover components before extraction. And finally, get code connect map, links Figma components to your files if you have Code Connect set up in your organization. And let me show you how each one works. Here's our primary button component in Figma with multiple sizes, states, and variants. And this is what we will extract. We ask Claude to extract the button design. Claude calls the MCP with the node ID, specifying Swift and SwiftUI as the target. The MCP returns type definitions, showing size variants, state options, and content types. And this is React TypeScript format, as you might notice. And it showcases current Figma MCP limitation, which is no support for SwiftUI, even though we can pass it as an argument. But Claude adapts it to the SwiftUI later anyway, so that's that's no big deal. And here's the actual function call: node ID, language set to Swift, framework to SwiftUI. And here's the raw response for the primary button you've seen before: image assets, type definitions, and a complete function showing a medium active text button with all styling. Claude get pixel perfect specs with color, spacing, typography, corner radius, and there's no manual measurement needed, which is pretty handful. And the next one, get variable defs, extracts your design system tokens. Look at this, like color values, typography specs, spacing units, and Claude can now generate code that references your actual design tokens instead of hard-coded values. And this keeps your implementation consistent with the design system. Get metadata is a discovery tool. So when you ask, like, show me all button variants in the design, Claude first uses get metadata to find them. It returns a lightweight structure showing what exists, 21 button variants in this case, and then you can drill into specific ones. This prevents you from missing variants or states. And get code connect map maintains the design to code mapping. So simply Figma node IDs are mapped to Swift files. It happens at the GitHub level in this case, because this is Figma and GitHub integration, as far as I know. So this is bidirectional, and designers can see which code implements their designs, and engineers can find the corresponding Figma components from code. And it keeps design and code in sync, making it easy for AI models to work with. However, it requires prior setup of Code Connect in your organization. So now let's see some workflows. The first one is design system audit. And you ask Claude to verify button sizes matches between Figma and SwiftUI. Claude uses get metadata to find all button variants and extracts each with get design context. Compares heights against primary button Swift file and then reports any mismatches. The second one is design token sync. Designer updates color in Figma. Claude calls get variable defs to pull new tokens. Compares with design system Swift file, design tokens Swift file, shows the diff, all primary colors versus new ones, and then updates the file and run tests. Third workflow is called adding component variants. Let's say that the designer adds an outline button style. Claude uses get metadata to find new variants at the beginning. Then get design context is called to extract specs, identifies differences, transparent background, stroke border, different text color, and then Claude extends your primary button and enum and updates implementation. Now moving on to Jira MCP for accessing your tickets and sprint details. Jira MCP has 5 core functions: search for natural language queries, then we have set Jira issue using JQL for advanced issue search, get Jira issue to fetch complete details, create Jira issue for bugs, stories, tasks, and edit Jira issue to update fields. So now let me demonstrate each. The search function uses Rovo search, which is Atlassian's natural language search that happens on their servers. And you ask in plain English, like find all high priority iOS bugs assigned to me. And look at what comes back. We have issue key, we have title, excerpt, container, URL, last modified date, and then Claude summarizes this into actionable information. So in this example, we have critical iOS 18 crash, and Claude is offering to show the details. This eliminates manual Jira filtering, so you don't need to exit Claude code. And here's how it flows. You ask what iOS bugs do we have in the current sprint. Claude calls the MCP search with the natural language query that you created, and then returns 3 bugs with priorities. So Claude summarizes them. So we have 1 critical iOS 18 crash, we have 1 medium dark mode issue, 1 low priority notification delay. And then you ask Claude for the details of mobile 1234, and then it fetches the full context. So you don't need to exit Claude code again. For precise control, you can use search Jira issue using JQL. Here I'm searching for project equals mobile and assigned to current user with status in progress. And I specify which fields to return to not overflow the context. So the response includes complete issue data. We have summary, description, status, priority, assignee, created date. And this is perfect for automated workflows that need structured data. Get Jira issue fetches everything about the specific issue. You provide the ticket key, in this case, mobile 1234 again, and get back the complete structure. So we have, again, summary, description, status, priority, all these fields, and the descriptions comes as a structured content, not plain text, and Claude uses this to understand full context before generating code or tests. Let's take a look at complete flow. So you ask, what are the details of mobile 1234? And Claude calls get Jira issue with the ticket key. Returns everything, all these fields like summary, priority, again, full list, and Claude formats this into readable output with context about relationship to parent epics and blocking issues. Creating issues is straightforward but powerful. You specify project, issue type, summary, description, priority, all these fields, and it gets created. In the response, you receive new issue key and direct URL, so you don't need to exit your terminal again. This workflow shows how this happens naturally. So let's say that you encounter a crash during development, and you tell Claude to create a bug. It looks up your account ID in Atlassian's cloud. It creates the issue with proper formatting and returns the ticket number. Later, you can add comments with attachments like stack traces from crash logs, and you can even ask Claude to do that for you because you don't need to switch the context again. And edit Jira issue function updates existing tickets. Change priority, add labels, update fixed versions, reassign, all these. This is essential for our workflow automation because moving tickets through states, updating them as work progresses is pretty important. So we have 2 real examples. First, bug triage. So you ask, show me all untriaged bugs from the last 3 days. And Claude runs the JQL to find them, then organizes them by priority. So critical issues are highlighted at the top, and like App Store rejections, payment for flow breakage. And this transforms a tedious triage process into a quick review of AI response. So second one is release management. You ask Claude about 2.5.0 release status, and Claude queries all issues for that version. Groups by status, done, in progress, blocked, all of these. Shows completion percentage and estimated date. Then you ask for release notes, and Claude generates them from completed issues. And this gives you release visibility without maintaining separate documents and leaving your terminal. Now the last MCP I want to cover today, which is Notion, where in our case, in my company, documentation and PRDs lives at. So just 2 main functions I wanted to cover today, search and fetch. Nothing unusual. Notion Search finds pages and databases, which is quite important when it comes to Notion. And you ask find all iOS architecture documentation, and Claude searches your workspace. It returns matches with IDs, titles, excerpts, URLs, last modified dates. In this workflow example, you ask about biometric authentication docs, and Claude searches, finds 3 relevant pages, implementation guide, security, best practices, architecture RFC, and then ask if you want to see the full content. So this is pretty important that, again, context won't be too big. And this beats manually hunting through Notion because you don't need to lift the terminal again. Notion Fetch retrieves complete page content, so you can use page URLs or IDs. And look at what comes back. Formatted markdown of your documentation, headers, lists, bold, text, links, all is preserved. The workflow shows how this works end to end. So you ask to see iOS architecture documentation, Claude fetches and displays formatted content showing your MVVM pattern, state management, repository pattern, and navigation. Then you ask about sprint planning, and Claude retrieves and query the database. Another real example, extracting requirements from PRD. So you ask Claude to find the biometric authentication PRD and show acceptance criteria. And Claude searches Notion, finds the PRD, fetches the page, extract the acceptance criteria section. You get structured requirements, like must-haves like Face ID, enablement, biometric prompts, fallback to password, everything. And this transforms a 10-minute search into instant access directly from your terminal. So we've seen MCPs, and they give Claude or any other AI agentic tool access to your tools. But having access isn't enough, and this is where subagents come in. So here's the key insight. MCPs give us tool, but someone needs to orchestrate them. And the Figma MCP can fetch a design, but it doesn't know your SwiftUI patterns. And on the other hand, the Jira MCP can create tickets, but it doesn't know how you break down features. So this is the missing piece, which is workflow orchestration. So subagents are pre-configured AI specialists that know how to combine all these tools. And they follow your defined processes, execute multi-step workflows, and critically, they know your standards and understand your conversions. So think of them as developers who've learned exactly one workflow, but pretty well. And the difference is crucial. An MCP fetches a Figma design, which is one action. A subagent fetches the design, extracts specs, implements SwiftUI following your patterns, creates tests, and opens the PR. So this is a complete workflow. And MCPs are tools, subagents are workflows that uses them. So here are 7 subagent specialists that we have in our company. Each one handles a specific part of the development workflow. So we have the first one, feature refinement, turns PRDs into technical tasks. Then we have screen implementation and design system component handle coding, repository tests and store tests cover testing, code practices reviewer ensures quality, and PR workflow handles the entire delivery process. And notice how they map to different parts of your workflow, like planning, implementation, testing, delivery. And you can use them independently or chain them together. So let's dive into each one. Our first subagent today is iOS Coding Practices Reviewer. And Elviro from our iOS core team built this together with Nico. So thanks to them, we have this set up. And because code reviews kept catching the same issues every time, like wrong SwiftUI pattern, inconsistent naming. And the secret sauce is that our coding standards live in the repo as markdown files. So we have coding practices, SwiftUI patterns, we have store conventions. And the benefits of that are Claude Code reads these automatically, and we have like no configuration needed, and your standards stay in sync with code because they are versioned together, so they can't go stale. And using it is pretty simple. You say review PR234 using subagent, and it grabs the div, compares against your standard files. Then it checks MVVM patterns, naming, SwiftUI standards, async await usage, whatever you want, and then the subagent posts feedback directly in GitHub. So we have line-specific comments that cite your actual standards, and it's not a generic advice, but it's your team's documented practices. So here's what it looks like in GitHub. So you can see that the bots commented with valuation, uses time interval since 1970, initializer instead of calendar-based date creation. So what it shows is the current code, it shows required pattern, explains why, so proper time zone mocking for parallel tests, and references coding practices, showcasing where it comes from. So this isn't a model's opinion, it's enforcing what your team actually agreed on. So the next subagent is feature refinement. This subagent transforms PRDs into technical tasks. We built it by feeding Claude with 8 PRDs that we've refined manually before, showing how we think about architecture, assesses risks, breakdown work. And it's not following generic PM advice, but it learned our specific approach, our task granularity, our story ports calibration that we learned over time. And the flow, you say refine the feature, and it asks which Notion doc, fetches the PRD via MCP, it reads requirement and acceptance criteria. If something is unclear, it asks like, what's the entry point? Are there any backend dependencies? Do you need a feature flag for this feature? Then it breaks the feature into tasks with story points and creates them directly in Jira. So let's say that 2-hour refinement session has become a 10-minute review of subagent work. Next one is repository test subagent that handles our data layer testing. So the key principles it follows are that tests live repository instances with mocked API clients are needed. It verifies the complete flow. So we have URL request generation, API response, decoded models, and we want to integrate with open API specs. So mocks can drift from real APIs. So actually, specs are provided by backend team, and based on that, we create tests. And it uses Swift testing framework because that's what we standardized on. And what it generates, it's URL request, verification test with correct responses, params, headers, body, according to Open API spec. We have responses, decoding tests, error handling tests, and mock API client implementations for these tests. So we have complete test coverage for your data layer. And let's see what this subagent's workflow looks like. So you say create tests for all repository, for example, and it asks which methods, checks for open API specs, analyzes the interface of your repository, and for each method, mocks API client with realistic JSON, captures the URL request, verifies URL headers, body, asserts responses, decoding, and then finally, it generates error cases. So the tedious part of writing disappears, but the comprehensive coverage stays because we are basing that on the open API spec. So store test subagents is the next subagent that we use to generate tests. In this case, business logic tests. So critical rules are that we test complete stores. So we never test the view state alone. We never mock effect handlers. So always mock at the repository level. And this ensures that tests verify the real state machine, not shortcuts to it. So the store init only exposes config params, never state. And you reach state by dispatching events. So it is what actually production code does. And thanks to that, our store test covers complete use cases, all generated by the subagent. And let's see the usage. The agent analyzes structure. So we have state properties, events, effect handlers, dependencies. And for each use case, the subagent sets up context with mocked repositories. It mocks calendar and time for determinism. It dispatches events. It verifies state transitions. And then it tests error cases and entry logic. So these are integration tests that actually validate your actual business logic. And the screen implementation subagent is where everything converges. So the subagent uses Jira MCP for requirements, Figma MCP for pixel perfect specs across all states, like loading, error, empty, all of them. And then it reads your coding standards, it checks Git to determine the file placement, then generates Swift UI following your patterns, Xcode previews for every state, basic UI tests, and navigation integration. So it takes design to implementation in one flow, basically. So let's say that you call Claude Code to implement profile setting screen. So it asks where this lives, suggests a path based on project structure. It fetches Jira tasks like requirement, acceptance criteria, link designs, and you select all design states in Figma. So it extracts spacing, colors as design tokens, typography, component usage, everything. And then it reads your coding practices and SwiftUI patterns. And finally, the sub-agent generates the code, which matches your requirements and coding practices. So day of implementation becomes like an hour of review. The next one is design system component sub-agent that has two modes. So the first mode is creating new component. So it extracts all Figma variants like sizes, styles, all of them, and it generates SwiftUI with proper enums, including like docs and previews. The second one is modifying existing components. So it checks current implementation with updated Figma, shows precise diff, and updates code, validating no breaking changes. If needed, it updates tests, stuff like that. And let's look at the creating a button with a following prompt. So we have create primary button component. And the sub-agent asks where and suggests design system /component /button path. You select in Figma with all variants you need, and it extracts like sizes, states, styles. And then finally, the agent generates SwiftUI with enums, previews for all combination, accessibility if you ask him to, documentation, consistency from day one. And the last one, PR workflow sub-agent, created by Nico from my team, automates the tedious part, which is writing PR descriptions. So it handles Git operation. It handles Git operation, uses Jira MCP for task context, GitHub CLI for PI creation, and it analyzes your changes and categorizes them. So in our case, we have title from Jira, organized change description, file by file summary, testing checklist, links to Jira to make sure that reviewer can access them easily, and breaking changes section. So it's basically professional PR descriptions in seconds. And let's take a look at the usage. So you say create PR for mobile 1234. Then sub-agent validates ticket format, fetches summary, description, acceptance criteria, all it needs from Jira, and later it analyzes Git changes, lists modified files, categorizes features, tests, config, generates description from your template, pushes branch, creates PR via GHCLI, and returns you the URL of the PR. And in my case, it's like 10 minutes of PR writing eliminated. And here's the result from 3 days ago. And you can see clean sections like Jira references, goal statement, implementation explanation with technical details, like specific changes made, developer checklist at the bottom when we have tests added, no warnings, team label applied. And at the very bottom, there's an AI assistant section documenting what Claude actually did versus human review. Because I think that transparency matters, and with that, reviewers know that the PR generation was automated. And you've seen our 7 sub-agents in action. Now let's talk about building your own. So this isn't a magic. We have 4 things to cover. The first one is anatomy, then we have tools, training, and pitfalls to avoid. So first, let's cover setup anatomy. So sub-agents are just markdown files in Claude agents hidden directory. So in our case, we have feature refinement, repository tests, store tests, Git workflow, and that's it. We have like no complex framework, no configuration system. It's just markdown files in a specific location, very specific location. So Claude Code can find them easily thanks to that. And each file has YAML front matter at the top with name, description, model choice, and color for UI. And believe me, choosing the color is the most difficult part if you're struggling with your coworkers. So yeah, pay attention to that. And below that is your prompt. So something like you are an expert at blah, 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 followed by your workflow steps, examples, references to other files. And it's structured and readable by a human. So in my opinion, you could hand this to a non-developer colleague and they would understand the process right away. And connecting to tools is very explicit. In your workflow section, do something like fetch Jira task using Jira MCP, call get Jira issue with ticket ID. So you match the instruction with the actual MCP call, or like below, we have create PR using GitHub CLI and run GHPR create with the title and body. So you match action with the actual MCP or CLI tool, and later on, Claude will find that very easily. So this wiring makes the subagent useful and more precise. And without it, Claude would wouldn't probably know what tools it has access to, or has to figure it out, wasting your very precious tokens. So training your agents is very simple, because it's like collecting example of you doing the same work but manually before. So we have past PRDs you refined. We have Jira comments on feature breakdowns. We have Slack threads where you explained architecture decisions to your colleague, to your managers, whatever. You have Notion docs, meeting notes, anywhere your work lives, and get a pretty various examples. So you can have simple cases, complex cases, edge cases, where you had to make a judgment call. That works best, in my opinion. So, for example, I used 8 PRDs that I refined over last 3 months. So then you can ask Claude to learn from them. So the prompt can be something like, here are 8 features refined I did, analyze the pattern in my approach, how I structure tasks, what I check for, my decision frameworks, update feature requirements file, subagent, to include these insights. So Claude identifies your implicit patterns very well and proposes a workflow. So then you refine, add the check for API dependencies or something, and Claude does it. So the key is to operate until it captures how you actually think. And then, once you've created that, do a reality check. So use the subagent on a real work. Notice what it missed, and add this as an example or adjust the instructions manually, then repeat. So the first iteration, in my case, is about 70% accurate, I would say, but I didn't measure that precisely, so it's just a guesstimate, and it gets the structure very well, but misses nuances. After 5 iterations of asking Claude to improve himself, it was about 85%, and after 10 iterations, it feels like mind reading, in my opinion, so it's pretty convenient. And this isn't one and done. It's a continuous improvement as your processes, the standards and conventions evolve. So let me wrap up with what we are experimenting with now at the company. So there are 2 directions we are exploring. The first one is composable subagent workflows. So we want to chain focus subagents into complete flows. The second one is CLIs over MCPs, and we want to use more context-efficient tools for simple operations. So both are about pushing the limits of what Claude can do by limiting its context windows. So the composable workflow idea, chaining subagents together. Screen implementation subagent builds UI from Figma, then repository test subagent generates data layer tests, then store test subagent generates business logic tests, and finally PR workflow creates the PR with everything linked together. So we would like to have one command that completes feature from design to ready for review. And yeah, that's our vision. The big unknown is, can context window handle this? Because each subagent loads its own instructions, examples, references. So stack 4 of these subagents together, and you might overflow your context window before completing the workflow, or even achieving the middle of it. So we need to measure this empirically, I would say. It might work, it might hit limits at 3 subagents, let's see. We don't know yet, so that's why it's an experiment. And the second experiment, CLIs over MCPs for simple operations. And the issue, MCPs load all their function definitions into context at startup. So even unused functions consume tokens. CLI's comments are cheaper because of that. So you just mention explicit comments, no upfront context load. So it's good. And we already do this for Xcode builds and GitHub via GHCLI. So context stays focused on actual work, not scanning all available tool capabilities. I missed a slide? No. We are planning to migrate Jira MCP to CLI for simple stuff because Atlassians released their own CLI tool. So we want to keep the MCPs for complex queries that benefit from structured data. And pro tip for you, disable MCPs you don't actively use when you are working with Claude Code or any other AI agenting tooling, because every MCP adds its function definitions to context from the very beginning of the conversation. So unused functions equals wasted token and burnt money, which you want to avoid probably, or at least your company. So when you are pushing context limits, every token counts. So yeah, that's our setup at Job and Talent. MCPs connect Claude Code to your tools. Subagents orchestrate them, orchestrate those tools. And yeah, I hope that you can build this with your team. You know the details of implementing subagents. The real value is codifying your team's workflows and your team's knowledge into reproducible workflows, I would say. So yeah, happy to take questions.
Two questions. The first one, thank you for the talk, of course.
I can't see you.
Oh, here.
Oh, okay.
The first question, do you see any downsides of such approach to your work? Or maybe what are downsides at your workplace or your team?
Yeah, downsizes, we lose quality a bit, of course, but the speed we are working at now is good enough reward, I would say, because when you create a bug, you can ask Claude later to fix that as well. So I would say that the downsides are more bugs, but if you spend more time on QA and testing your implementation, it's still like better in terms of money and time.
Okay, thank you. The second question: have you tried to combine the Claude skills into that concept and your workflow? Like, I think you have like coding practices that might be a Claude skill, but I'm not sure if you try to convert that to the skills yet.
We have experimented with skills in the company in the front-end team, but in my cases, we stick to the sub-agents for now because they do their job. I'm not an expert in skills, but what I think of skills of is you can access it from Cloud or some other repository that it exists at, and you can you have a pretty generic stuff, but they are not that specialized as sub-agents that have access to your work to your repository and files in it. So in our case, it's okay to have that in each repository because we have iOS common practices repository with GitHub Actions that automatically propagates this file to other repositories. So that's why skills in our case are probably something we don't need. But yeah, that's a good suggestion.
I wanted to try to expand your answer for one of the previous questions. You mentioned that you lost a bit of quality. And during the talk, you also mentioned that you switched a day of development into an hour of code review maybe not code review, but the agent's work review, right? So I was wondering if you are actually tracking those metrics. Do you have any data what your speed versus amount of bugs was before and how it changed and evolves after introducing this, to see if you maybe, because a feeling of the reward is greater than the bugs that we get from this, right? It's a nice feeling because you are very fast, you push tasks out, users are maybe even happy because of that. but there might be a point where you spend more time testing an agent that you lose kind of concept of how they work versus the time you'd use to develop it yourselves. It's a bit loaded, but would be very happy to hear your thoughts on this.
Yeah, sure. That's a good question. Thanks. So, as always, it depends. So, maybe let's divide it into multiple questions. So, regarding the measuring of the performance, we don't sum up the amount of time we spend on each feature by implementation plus the fixes after QA. But what we track is every feature is estimated in the same way as we did before. So what we see is that when we sum up the story points we do during the sprint, after the sprint is finished, it's like 2 times what was before we used the agenting tooling. So even with the QA fixes that we do during the sprint, the speed is definitely increased. We don't track this like in detail, but overall amount of story points we do during the sprint has significantly increased. And yeah, regarding your second question, it depends, because if it's like the fixes, internal bugs in Jira, stuff like that, the boost that you gain from AI agenting tooling is not that significant. And what is the easiest way to see the boost is brand new screen, when there is no like fixes or modifying some legacy code, but implementing brand new screen when you have new feature, the definition acceptance criteria is pretty clear. This is where the boost is most easy to see, because you don't need to even provide the details and the context to agent about the legacy knowledge and what should the agent like be aware of. But with the PRD and stuff like that, it's very clear for the agent to like what's the desired result. So yeah, it depends, and I would say that it depends on the scope of the task and how big it is.
Hey, I have a question. How long did it take for your team to get to the point that you are now? Or let's say one part, if I want to, convince my guys to start using this approach.
So it depends on your current setup, because if you have pretty like big amount of documentation for example, in my case in Notion, but anywhere in your company, you can ask Claude to review it, and you can provide all these documents, and based on that, generate these sub-agents and all these files that it will later use. But if you don't have this kind of documentation and you need to actually create it from scratch, it will take much longer. So in our case, creating the GitHub PR workflow was like 2 hours, by just providing the documents, generating the sub-agent file, and later adjusting it manually. It was only like 2-3 hours maybe.
So I have an interesting question. For how long have you been using this approach? And how do you feel about not the results, but the progress during the work, day-to-day work? For example, you code, it's like ChatGPT, right? You ask something, it ask, answer. Only text. Isn't it a bit boring? For example, when I switched to, for example, Slack, Figma, there are many different views. I got something interesting, and then I start working in one mood maybe sometimes. But if it is only text, how do you feel about it?
Yeah, good question. So for me, it's okay, because during other meetings like kickoff meetings and something where we discuss the feature or want to spot potential dangers, we see the Figma, because the designer is sharing the Figma. So it's not like that I'm fully unaware of what we are gonna work on. But in my case, it works very well. It was not covered in the talk, but I use Conductor to run multiple agents using Git work trees, I guess. I might have used the wrong name, but yeah, it doesn't matter. Basically, you have separate Git workspaces. And yeah, thanks to that, I can run multiple Claude agents in parallel. So when I'm waiting for Claude to finish in the first window and the first workspace, I basically switch to the second one and do another prompt, then wait for a result. So you can check the conductor.build website, I guess, and yeah, I definitely recommend it.